Hi, in this video, we will see detailed review of Arduino's OPLA IoT Kit. We will see its features, specifications, getting started guide, and we will also see demo project, which will show features and different capabilities of this kit. So, let's get started. Hello all, welcome to Make to Explore channel. First of all, thank you to all our subscribers, viewers and supporters. In this video, we are going to unbox and review a product, OPLA IoT Kit. This kit is very useful and ideal for getting started with Internet of Things fundamental concepts in easy way. So without any delays, let's get started. Generally, to build any IoT project prototype, what will be the important components? So, typically, we must require a microcontroller board with connectivity to Internet. This MCU board supposed to be a brain of the project, which should be enabled with either connectivity option, like Ethernet or Wi-Fi, or both. Then, we will also require some sensors to get the input data from surrounding environment, like temperature, humidity, light, proximity, moisture, gas, etc. We also need some output devices, actuators, or control elements to control the equipments or devices, like relays, motors, lights, buzzer, etc. We also need some display devices to see what is happening around. And finally, we also expect this project should be constantly powered, stand-alone as uninterrupted service. What if all these requirements of typical IoT project comprises in one device? Then it will become very easy to build such a project, and also very useful to understand the basic concepts of Internet of Things, fast prototyping, and testing the proof of concepts. OPLA IoT Kit makes this possible because this kit consists of Arduino Maker IoT Carrier, plus Arduino Maker Wi-Fi 1010 development board. The carrier board consists of OLED display, 5 capacitive touch buttons, 5 RGB LEDs, on-board sensors like temperature sensor, humidity sensor, pressure sensor, light sensor, IMU sensor, gesture sensor, RGB color sensor. Also facility to connect proximity sensor, soil moisture sensor, etc. Then carrier board also have 2 analog compatible groove connectors, 1 I2C compatible groove connector, 2 24 volts relays, micro SD card holder, buzzer, and Li-ion rechargeable battery holder with charging circuitry. You can see an animation provided by Arduino about how the battery should be installed in carrier board. This is how complete kit, the OPLA IoT Kit looks like. In addition to this, OPLA IoT Kit includes a special code that allows you to claim 12 months of the Arduino Maker plan for free. The Arduino Cloud Maker plan included in the kit offers unlimited compilation time and extended access to all the features of the Arduino IoT Cloud, allowing the users to save more sketches, increase the number of properties, and get support for third-party boards and LoRa devices. So, now, let's unbox this device. Here you can see, this is an Arduino OPLA IoT Kit. This is an open programmable IoT platform, which comes with 12 months of the Arduino Maker plan for free. On the back side, as they shown here, this kit includes Arduino Maker IoT Carrier with colored display, different sensors, relays and buzzer, etc. Also contains Maker Wi-Fi 1010 board, and these other stuff. They have given documentation of these 8 connected projects. We can build all these projects using this kit. Okay, let's open it. Here on the left side, you can see some information given to get started with this kit. For fast and easy setup, the 12-month subscription code for Maker Plan will be given here. Please note that you can use it for only one time. On other side, here is the Maker carrier board. When you open or pull out this left side compartment, inside it, you can see here is the brain of this kit, Arduino Maker Wi-Fi 1010 board. Here is the plastic enclosure, then soil moisture sensor and motion sensor. You can pull this all out. Let's take out the carrier board also. You can see how beautiful this carrier board is. There are also some connectors and cables included in the box. These must be for connecting sensors. So, here are all of the included components in OPLA IoT Kit. Now let's see one by one. So, you can see, this is capacitive soil moisture sensor. Then, here is Arduino Maker Wi-Fi 1010 board. Let's open it. This is beautiful, isn't it? This board plugs into this IoT carrier board. This is Maker IoT carrier board, which have these touch sensors on the front side and round OLED display. Then, on the back side of this board, there are SD card and battery holders. Then there is place for Arduino Maker Wi-Fi board to fit in. Here, in this header, let's see how it gets fit in. So, you can see, both of these components have proper pinout notations. Silk screen. You just need to match, or align them properly, like this, and then gently push the board into header. Okay, let's see how to connect other sensors like motion sensor to this carrier board. Here is the carrier board. On its back side, there are 3 groove ports to connect the sensors. Now, let's connect this motion sensor. This has 3 pins. Please check pinout diagram before connection. On this IC's side, there is ground pin. Let's connect this groove cable to pin header. Like this. Okay, you can check out how this is connected. Then next, connect its other end to carrier board. We have already explained this in presentation, that OPLA Kit have 3 groove connectors, 2 analog and 1 I2C. You can connect proximity sensor to any analog port. Like this, you can see here. Now, on second analog port, we will connect soil moisture sensor. This is a capacitive soil moisture sensor. You can connect it via groove connector cable. Like this. Alright, now we connected both the sensors. Now let's see how install the battery. To enable the charging of the battery and providing power to Maker board, we have to connect cable between these 2 ports. Let's see. Like this. Then next, we will place the Li-ion battery in this holder. You can see, this is a battery cell. This is 3.7 volts, 18650, Li-ion cell. Okay then, here, pay attention on polarity of the cell. Its positive and negative sides. Most of the time, you will find markings of polarity on cell, as well as on carrier board. Okay then, install it properly. So, you can see, as soon as we put battery, kit starts. LEDs started blinking. Let's place this OPLA kit down. Earlier, we have loaded the demo code into OPLA kit, but why it is not running? Oh, I get it. To start, or run that demo program, we need to reset the Arduino board. Here is the reset button. Press to reset it. Then you will find nice-looking Arduino logo on OLED display, showing that demo have been started successfully. In this way, we have seen how to assemble the OPLA IoT Kit. Now, let's visit its website. Here is the one, opla.arduino.cc. Here, on this website, you can see they have given all the info to get started with this kit. Like, they have given 2 guides here. Part 1 is discovering the Maker Kit. And second part is setting up OPLA IoT Kit to the Arduino IoT Cloud. We will see both of these tutorials. They have also given 8 different projects built around this kit, with full DIY documentation. For example, remote-controlled lights, personal weather station, home security alarm, smart garden, inventory control, etc. Up here, in this first tutorial, discovering the Maker IoT carrier. Going into further details, you will find an introductory project serves as a demonstration of the hardware capabilities of the Arduino OPLA IoT Kit. If you go further into this guide, you will find Assembly of Kit, How It Works Guide, Getting to Know the Carrier Kit. Information about all the included components, like Arduino Maker Wi-Fi 1010 development board, their assembly, sensors, configuration of demo program, and also detailed step-by-step guide. We will see this all in demo. In the same way, there is another guidance tutorial for getting started with Arduino IoT Cloud. In this introductory activity, we will learn how to set up the Arduino IoT Cloud. It is a service that allows us to control and monitor devices over the internet. Inside the cloud, we can create things that are practically the digital twins of our hardware devices. So, in this tutorial, you will get all the information about assembly of the kit, guide to activate the 12-month Maker plan which comes with the kit, then how to set up the Arduino IoT Cloud. We have covered all these things like creating thing on Arduino IoT Cloud, then how to configure the device, how to create variables, how to enter your Wi-Fi network details, how to create dashboard, how to edit code or sketch on online web editor, and then how to upload the code into your Arduino board to monitor the changes in the cloud. Finally, how to access the data through the cloud dashboard. All these steps we have explained in detail in our previous video about Arduino IoT Cloud, Maker Wi-Fi 1010 board, and DIY project of basic thermostat system. You can click here on I button to check that tutorial for more information. Links are also given in the description of this video. Now, let's see demo project on OPLA Kit, which shows all the different capabilities of this amazing kit. For that, let's visit this guide on OPLA website. This is Build It Yourself tutorial, given here. Let's explore it. As they have mentioned here, let's get started with the Maker IoT carrier and become familiar with some of the core programming terms that is used in the OPLA Kit. Here, the note says, this project serves as a great introduction to the hardware of the Arduino OPLA IoT Kit, and it is recommended to go through it before attempting any of the other fun projects. It is also a good idea to come back to this project if you want to refresh your knowledge on how different components work and how we can use them in a sketch. So, the learning objectives means the goals of this project are: first, learn about the different components of the Maker IoT carrier. Next, learn about the Maker IoT carrier library. Then, learn how to use it in a sketch. And finally, build a basic application that introduces all the functions. For this experiment, we are going to use Arduino Maker Wi-Fi 1010 board, and of course, the Maker IoT carrier board, and micro USB cable. So, as we already mentioned, Arduino Maker Wi-Fi 1010 is the brain of the OPLA kit. You can check out our video about this board, where we have explained its features and how to connect it to Arduino IoT Cloud. Then, here is the Maker carrier board. Suppose if we want to read the temperature, play a sound, flash a light, or show things on a display. Building the such circuit alone would take a very long time. However, the Maker IoT carrier has all the small sensors and circuits already built in, giving us more time to focus on programming and to create amazing and unique applications. We have already seen how to assemble this carrier device to Arduino board, like this. Then next, about the plastic casing. If we want more portability to our project, we can place the Maker IoT carrier in the plastic casing, which comes with OPLA kit. It provides good protection for the hardware and makes it easier to attach it to surfaces, for example, a wall, partitions, etc., while also providing a nice glow for the RGB LEDs. They have shown this simulation about how to assemble the plastic casing. You can check this out. Alright, now, before going forward, there is one important note given here. The IoT carrier board have 5 capacitive touch buttons. Let me show you. Here they are, a round OLED display. So, in the note, they have instructed that the capacitive buttons work with the Maker IoT carrier, even inside the plastic encasing. But we, however, need to state this in the program. We need to modify or update the code in such a way that, in the void setup loop of each program for this kit, the code line saying carrier_case equals false will need to be replaced with carrier_case equals true. The buttons are then calibrated to detect button presses through the plastic encasing. Okay, next, about powering the device. The OPLA kit can either be powered directly through a USB cable from your computer, or by using a 18650 lithium-ion 3.7 volts battery. Carrier allows you to recharge your battery if it gets discharged. Every time that you connect the USB cable to the Arduino board, it checks if there is a battery attached. If so, it starts charging it automatically. Please note that, if we choose to use a battery, we do not have the option to view anything in the serial monitor. This is because the board is not connected to a computer directly, so there is no serial communication. Okay, now we will see how to program this OPLA IoT kit. For that, we will use Arduino Web Editor. If you are planning to use the web editor in your browser, then it is recommended that you use Mozilla Firefox or Google Chrome browsers. Here is the link to the guide they have given for getting started with the web editor. So, why web editor? The web editor is a great choice for working with your Arduino board. It stores all of your sketches online, requires no installation of cores, and includes most of the popular libraries. Here, all the information is explained with different screenshots. You can check that out for more information, but we will see this in brief. So, if you want to program your OPLA IoT kit using Web Editor for the first time, you must download and install the Arduino Create plugin, or Create Agent. It is software which recognizes Arduino boards and other supported devices connected to your computer via USB. It is an agent between your hardware and online web editor. So, let's see how to install it. For that, go to this link. Here, these are features of Arduino Create Agent. Means it recognizes Arduino boards. Upload sketches from your web browser to your boards via USB or network, and also read-write data for serial monitor. Okay, let's start. Here, click on these buttons according to your computer's operating system. It will download program file in your Downloads folder. Install with instructions given there. Let's go to Downloads. In Downloads folder, here is the setup file. Let's install it. Install as per instructions given on screen. There will be one security warning about certification. Just click Yes to install the certificate. Allow any firewall access prompts if appears. When installation get complete, you will see gray icon with Arduino logo in taskbar tray, like this, showing that agent is running and is ready to detect any Arduino boards you connect through USB ports of your computer. So, we have seen the procedure to install the Create Agent plugin. Now let's see the Arduino online web editor in detail. How to access it? Let me show you. In web browser, on Arduino IoT Cloud dashboard, you can go to web editor by clicking this button. It will get open in another tab. Please note that. Here you need to sign in to your Arduino account. If you don't have an account yet, then you can create one. We already have it, so let's log in. This is web editor interface. Here, first you should select your correct board. Like said here, select both a board and a port if you want to upload a sketch. If you only select a board, you will be able just to compile, but not to upload your sketch. If you installed the Arduino Create Agent successfully in last step, then your board and its port will get automatically listed here. Here, with this button, you can create a new sketch, create new folder, or import. Like our offline Arduino IDE, this web editor also have examples, libraries, serial monitor options, etc. Here in the libraries, you can search any library, or you can import custom library if you want, but just remember that it should be in zip format. You can also go to Library Manager to explore or sort more, according to boards or topics. Here, this is a compile button, and this is upload button, which will get enabled when your board is connected to correct COM port. With this 3 dots button, you can save, download, or share your sketch. This is tab button for adding new tabs, or importing any file into Sketch, like header files or secrets file, etc. And finally, this is your console log window, where you will see verbose log of programming, compiling, and uploading. Alright, this is about Arduino's web editor. Now, let's go back to our IoT carrier program. Let's take a brief overlook on this code explanation. We will now take a look at some essential functions that we can use from the MKR IoT carrier library. This includes the initialization, setup, and loop of a sketch. Practically speaking, the code used in the initialization and setup is rarely changed, and it is required in every sketch. Here they have explained it with code snippets in their descriptions. Here, they have explained procedure for how to gradually build the code for Maker IoT Carrier, step by step. Like how to include important libraries and initializing variables. We begin by including the libraries necessary for the MKR IoT Carrier in the sketch to function. Arduino MKR IoT Carrier includes the necessary functions to control and read components on our physical carrier. Visuals.h and Pitches.h are locally made libraries to include visual and musical codes that we will use in our sketch to display images on the OPLA screen and to play some sounds. After including libraries, we create the object carrier, which we will use throughout the program. We then initialize the variables, arrays and objects that we will need to access later in our sketch. Those include a string state, integer count, and unsigned integers, color red and color green variables, arrays of integers melody and note durations, and finally, a set of functions that represents different pages in our sketch. Then next, we will go through each of the functions that we declared in our sketch and are called in void loop. The void configure sets the configuration of the OPLA IoT display. This includes the right colors, font size, position of the cursor, and the loading animation. Next is the verification page for all the buttons on your OPLA IoT Kit, written with the function void touch page. This function prints a text that asks you to check all buttons and provides feedback when each of the buttons are pressed successfully. After checking the buttons, it's time to test the on-board sensors. The MKR IoT carrier is packed with temperature sensor, humidity sensor, pressure sensor, to collect data about movement using the 6-axis IMU, or MEM sensor, light sensor, gesture sensor, and proximity sensor. The void sensor page function is built to guide you in testing those sensors on your carrier. The code for displaying temperature, humidity, and pressure are shown in blocks. Each contains text representing the sensor, a visual and a reading of the value storing in a float variable. The next sensor to test is the accelerometer, which we will do by shaking our MKR IoT carrier. The given code checks the availability of data from the accelerometer and reads its values on all three axes, X, Y, and Z, when available. The next task is detecting gestures. This code given is set to detect movement on the 4 directions, up, down, right, and left using a gesture sensor. The last task is testing the 2 relays on the MKR IoT carrier. We are going to do that by controlling each of the relays, closing and opening, and assess their response. If the relay is responding well, we can move to the next page and continue the testing. When all functions are tested, the carrier will play a closing melody. The melody will iterate over the 8 notes defined in the pitches.h library. Okay, so this was all about the coding overview. You can go to this link of OPLA website and study in more detail about each and every code snippet for more information. Now, let's go to end of this document. Here, the full code of the demo for OPLA Kit is given. Let's import it to our web editor. Here is the download sketch option. Let's click on that. It will download complete code as a zip file. Save it in downloads. Then, click this open code button to open the web editor. It will open a new tab. Go to web editor. Here it is. To upload a sketch via USB port, make sure that agent is installed and running on this computer. Okay, now let's import the OPLA Kit demo code which we have downloaded. Go to this import button, click here. Then this pop-up will show some info. Click on import. It will open the file explorer. Then select this OPLA activity zip file. Click open. It will take some time to import. Finally, sketch successfully imported message will be shown. You can see here is our program in Sketchbook with supporting header files. As you can see, the code is self-explanatory, which is given with proper comments. We have already seen all code in various parts and snippets. Basically, what is this code about? So, in a nutshell, this program is written for testing and demonstrating all the functionalities of OPLA IoT Kit. It will check for working of each of the peripherals, sensors, and features included in this amazing OPLA Kit. So, you can see here, these are the 6 pages. Functions for different testing cases. Once you see the actual demonstration, you will understand their importance, why and where they used. So let's upload this code. Okay, so now, let's see the demo. For that, first we have to upload this activity code to OPLA Kit. Means it will get uploaded to development board of OPLA Kit, which is nothing but the Maker Wi-Fi 1010 board. We have already shown this in earlier part of this video, that how to assemble this OPLA IoT kit. Alright, now let's connect our OPLA Kit to our laptop and program it. Once you connect the OPLA IoT Kit to PC via USB cable, Arduino Create Agent will detect the Maker Wi-Fi 1010 board automatically. If this do not appear, then check two things. First, check Arduino Create Agent installed properly, and it is up and running. Secondly, very important, please use either Chrome or Firefox web browsers. Other web browsers are not supported by Arduino Create Agent. Okay. Now let's compile the code. Click on this Verify button. This will compile the project. It will take time. Once compiled, it will give message of successfully compiled. Okay, now you can see Upload button also got enabled. Click on it to upload the code into your Maker Wi-Fi dev board of OPLA Kit. Once the code gets successfully uploaded, you will see the demo program get started. Follow the instructions given on display to stepwise walk through the program. In this activity, you will learn different capabilities of OPLA Kit and the carrier board. Okay, so in this way, we have seen brief overview of Arduino OPLA IoT Kit. We would highly recommend this kit for learning basics of Internet of Things and fast prototyping of IoT proof of concepts. In upcoming videos, we will try all the demo projects which they have given on their website. All the important links are shared in the description. Stay tuned for more projects and tech updates. If you face any difficulty in replicating our DIY projects, feel free to ping us on Telegram or WhatsApp. You can also send us email at info@make2explore.com. We would be happy to help. Thank you.